There are 8 main steps in designing and building a solar array. The first, preliminary system sizing, the interconnection application, system design, permitting, site preparation, installation, commissioning or turn on, and then asset management or operation and maintenance. We will now review each step in greater detail. Preliminary system sizing has 3 main steps and some key pieces of information we need to understand. How much area do we have, and how many solar modules can we install there? Who will be buying our power, and how much power do they actually need? i.e., is this the utility, private enterprise, some other entity? We are connecting this project to the utility grid. How much power can the grid infrastructure handle? Transmission stations and grids can only handle the input of a certain amount of energy. Typically, the older the technology on the grid and the more dense the population in the area tends to restrict the amount of power that the grid can absorb. Without the proper grid capacity and allocation, projects may not be able to go forward, i.e., be connected to the grid. There are certain tools such as SketchUp and Helioscope that can be used to aid in this process, i.e., in terms of laying out the array. The interconnection application is the process in determining and reserving grid capacity, as well as getting approval from the local utility. During this step, we have to submit an application to the local utility to determine if they have capacity on their grid in order to connect our system. The connection impact or interconnection application is reviewed by the utility to determine if the grid is able to handle the additional load. It should be noted that if the system is off-grid, this step is not applicable. System design. A solar array design consists of both mechanical and electrical components. It is often a trade-off or optimization of many different factors. Here are but a few of the considerations. First of all, on the mechanical side, the higher the tilt of the array, the more solar production we will see from the array during the winter months. However, it should be noted that the higher the tilt, the higher the wind resistance, and thus the higher the stress on the foundation, or in case of a rooftop, the higher the weight of the ballast that may be used to hold the array in place. There's a need to lay out the array so as to ensure the solar array is facing in the right direction with respect to the sun, due south. Modules installed in the shade will receive less irradiance and will produce a lower amount of energy than other modules. In other words, we have to do what's called optimize for shade. Electrical. We need to ensure that the AC to DC ratio is appropriate. In other words, DC is about 20% higher than AC power capacity. This ensures the most cost savings and typically the highest output. Cable sizing and lengths. The farther electricity has to flow through wire, typically there are more losses. This is a balance between the loss of electricity and the cost of cable. We also have to ensure the connection meets grid and utility regulations. This chart or graphic shows the optimal angle for fixed solar panels depending on the installation position. So in other words, where you are in relationship to the equator. As you can see, as you move farther away from the equator, either north or south, the higher the panel angle. Like many construction projects, the installation of a solar array requires permits and authorization to connect. The required permits vary by country, state, and municipality. Examples of some requirements may be general construction permit, fire department authorization, and an electrical authorization. Please check with your local municipality to determine what is required for your project. During installation, the project is brought to life. At this phase, the physical labor begins. Typically, the EPC or construction company will start to erect the solar array. This usually starts with the foundational elements, that being the array itself. For the array, it will start with the racking, the cable trays, then the wiring, then the panels, combiner boxes, and then home runs to the inverter. At the inverters, it will be the foundations, the concrete foundations, the cable ducting, inverter, transformers, disconnects, etc. Finally, the hookup to the grid will be performed. Here is an example of racking and panels. The racking is mostly constructed of aluminum. There are some steel racking components, and then panels are affixed to that rack. The example here is one of a ground mount installation. Here is an example of a rooftop installation using string inverters. You can see the inverters red and gray along the top wall with cable trays, cables coming back down to the panels that are mounted in place on top of a rooftop by example. Commissioning is the final step within the construction process. It ensures that the array meets the required benchmarks. The commissioning sequence is a series of tests to ensure that the site is performing as designed. In addition to this, critical safety tests are carried out and the site is tested to function properly under load. The commissioning sequence begins once the site is assembled and some go-no-go tests are performed. The commercial operation date, or COD, is the date a site is fully tested and commissioned and connected to the grid. It can start to produce power. During the asset management phase, or operation and maintenance phase, we should be reminded that even after construction, a solar site needs to be checked regularly. Once the systems are operational, periodic monitoring and maintenance are required. Most sites are equipped with a monitoring and alarm system that will alert an operator if the system suffers a fault or stops operation suddenly. Operators can generally remotely access the system to interrogate it with respect to its performance metrics. In this way, a responsible operator can ensure that the system is working properly and can proactively identify faults. Congratulations on finishing this section. Once again, we reviewed the preliminary system sizing. That is the area that we have to work with and the connection strategy, etc. The interconnection application, in other words, the application we need to provide to the utility to connect to the grid. We reviewed briefly the overall system design and some of the parameters, both mechanical and electrical, that one has to consider. We looked at permitting, construction permitting, electrical authorization permitting, site preparation in terms of what needs to be done at the site itself, installation, so everything from the racking through to the connection,